in this video, we are going to learn how to name molecular compounds or molecules. But first, I just wanted to remind you how to tell the difference between a molecule and an ionic compound. So we could also call those covalent versus ionic compounds. So remember, compounds that are composed of only nonmetals or semimetals with nonmetals will display covalent bonding. So off to the right, I have just an example. We have two nonmetals. So this could be hydrogen and fluorine, just as an example. So these would be classified as molecular compounds. So if you only see nonmetals, it's a molecular compound. And then compounds that involve a metal binding with either a nonmetal or a semimetal will display ionic bonding. So this might be sodium and chlorine as an example. So this is why it's important to remember where the metals are on the periodic table and where the nonmetals are. We won't deal with the semimetals as often, but just keep in mind that semimetals could show up in either scenario. And then also don't forget that ionic compounds could also include polyatomic ions. So remember, the polyatomic ions are composed of two or more atoms, and they have a charge as a group. So now that we know more about covalent bonds, we can go back and understand polyatomic ions a little bit better. So in a polyatomic ion, you have non-metal atoms that are joined by covalent bonds. But the entire thing has a charge. So the entire non-metal atoms with covalent bonds, they are going to participate in ionic bonding. So if we look at the ammonium ion as an example, nitrogen and each of these hydrogens, those are all nonmetals, and they have covalent bonds with each other. But the entire thing has a positive charge. So that is going to participate in ionic bonding. So it's like the what's that movie, The Matrix? It's like covalent bonds within an ionic bond. And then the carbonate ion, we have carbon and 3 oxygens. So these are all non-metals. So they're all participating in covalent bonding. But the entire thing has a -2 charge. So that whole thing is going to participate in ionic bonding with a metal ion, for example. All right, so a little confusing, but hopefully makes more sense now that we know more about covalent bonding and ionic bonding. So let's focus just on molecules or molecular compounds, and let's talk about molecular formulas. So typically, when we write a molecular formula, we begin with the nonmetal that is closest to the lower left corner of the periodic table. However, hydrogen is never written first except for H2O. That's our one exception. And then we list the other non-metal symbols, and we use subscripts to indicate if there's more than one of those atoms. So in general, when we write a molecular formula, we're typically going to start with carbon. And then we would include a subscript if there are multiple carbons in the molecule. Then next, we usually write hydrogen. After that comes nitrogen, then oxygen. I'll just put an A there as a subscript, and then we would do the halogens. So let's say chlorine. So that's going to be kind of this corner here of the periodic table. And those are the atoms that we're going to see the most of in this class. So typically you'll notice that the order of atoms is carbon, hydrogen, nitrogen, oxygen, and then the halogens. Now, of course, there are going to be some exceptions to that. So if nitrogen is the main central atom, that would go first, followed by any other atoms. But most of our compounds contain a lot of carbons and hydrogens, so those will be present most of the time. All right, so let's practice naming molecular formulas. So let's say that we have a two-element molecule, also called a binary covalent compound. This is going to be really similar to naming simple ionic compounds. So what we'll do is the first element in the formula is just listed using the name of the element. So the first element in the formula, we're going to use the name of the element. And then the second element will be named by taking the ending of the name, chopping it off, and using the suffix IDE. So again, very similar to how we named ionic compounds. So we just named the first element and its name, and then the second element we took off the ending and replaced it with IDE. So down below we have CO2. So we would just name the first element carbon. We don't change it at all. And then the second element, we're going to take the name oxygen, chop off the ending, and add IDE, so it becomes oxide. Now, the other thing we need to do is we need to indicate how many oxygens we have, because we have multiple oxygens in this molecule. So we're going to use the prefix di before oxide. So then it becomes carbon dioxide. So let's look at a table of prefixes that we can use to indicate how many of each element we have in the molecule. So again, a system of numerical prefixes is used to specify the number of atoms in the molecule. The one exception is, let's say you have only one of the first element. We don't use a prefix with that first element. So let's say you had just one of the second element, then we use that prefix. So let me clear it up a little bit. So let's look at carbon dioxide. So even though we only had one carbon, we did not call this monocarbon dioxide. We just left the first element alone and called it carbon. However, let's say you had just CO. So the second element was by itself. Now we're going to use that prefix mono. So it's carbon monoxide. So don't ask me why they do it this way. It's just how they do it. Just part of the rules. I didn't make them, I just follow them. All right, so let's look at some of these other prefixes. So let's say you have two of something. Then the prefix is di. If you have three of something, it's tri, and then followed by tetra, penta, hexa, hepta, octa, nona, deca. Now, most of the time, we're just going to be dealing with these first five, for example. There might be a couple times where you'll see 6 or 7 of an element in a molecule. But in this class, we deal with simpler molecules. So as long as you have those first 5 prefixes memorized, you should be good. So just make sure to know these prefixes. Okay, so let's do some practice problems for naming. Let's name the following compound. So we have NO3. So we have a nitrogen by itself. So again, remember, we're not going to call it mononitrogen. We just leave it as nitrogen, because we don't use mono with the first element, only the second element if it's by itself. Now, we do have 3 oxygens, so the prefix for 3 was tri. So tri, and then remember, we named the second element similar to how we name the nonmetal ions. So this would be oxide. So this molecule is nitrogen trioxide. All right, so let's look at some more. Let's see if you can name the following molecular compounds on your own. We have PCl5, CF4, and N2O5. So I'll let you try these on your own first, and remember, you can go back to that prefix table if you need to, and then when you're done, we'll go over them together. All right, let's look at the first one, PCl5. So remember, we just named the first element as its normal name. So P stands for phosphorus. Let's see. Oh, I always misspell phosphorus. It's US at the end. There we go. Phosphorus. And then how would we name chlorine? So we do have 5 chlorines, so we need to use the prefix penta. And then remember, with the second element, we chop off the end and add IDE. So chlorine would become chloride. So phosphorus pentachloride. All right, the next one is CF4. So again, we just named the first element how we would normally name it, which is carbon. And then we have 4 fluorines. So what's the prefix for 4? Tetra. And again, similar to chlorine, we're going to chop off the end of fluorine and add IDE. So that becomes fluoride. All right, and then last we have N2O5. Okay, so now we have multiples of the first element. So now we get to use a prefix with the first element. So what is the prefix for 2? Di. So dinitrogen. And what was the prefix for 5? It was penta. And then oxygen is going to become oxide. Now, notice that we have 2 vowels next to each other. Pentaoxide. So that's a little bit awkward. So what we actually do is we just get rid of the A. So it's actually going to be pentoxide. Now, let's say on an exam you forgot to drop the A on penta. I'm not going to, take any points off, because at least I know that you know the prefix and the name for the second element. But in general, when you have 2 vowels next to each other from the prefix and that element, we tend to drop the first vowel. Now, one thing to remember is when we were naming ionic compounds, we were not using prefixes, right? So no prefixes when you're naming ionic compounds. But now with covalent compounds, we are using prefixes. So the reason that we do not use prefixes with ionic compounds is we're supposed to know the charge on the element or the ion. And so knowing the charge, we don't need prefixes because we can just figure out from the charge how many of each ion we have. But with covalent compounds, we don't have charges, right? Everything's sharing electrons. And so we need those prefixes to indicate how many of each element we have. For example, let's go back to carbon monoxide and carbon dioxide. If we didn't indicate how many oxygens were in each molecule, there would really be no way to know, right? So there is a huge difference between carbon monoxide and carbon dioxide. Carbon dioxide is perfectly safe. Carbon monoxide is kind of dangerous for us because carbon monoxide can replace oxygen in our bodies, and you can actually end up poisoning yourself with carbon monoxide. And that's why we have carbon monoxide detectors, or we should have them, in each of our homes or residences. But carbon dioxide is perfectly safe, right? So it's important to indicate how many of each oxygen you have, or else you could be telling someone the wrong thing, and that could be dangerous. So with covalent compounds, we do need those prefixes, but ionic compounds, we don't need them because the charges are going to tell us how many of each ion we need. All right, so let's go backwards. So let's say I give you the name for a molecule. Can you write the molecule's formula? All right, so I'll let you pause the video and try it on your own first, and then we'll go over it together. All right, let's look at sulfur dioxide. So there is not a prefix in front of sulfur, so that tells me it's by itself, and its symbol is S. And then di tells me that I have two of the next element, and oxide means we have oxygen, so O2. So the molecular formula is SO2. The next one, carbon tetrachloride. We don't have a prefix in front of carbon, so that tells me it's by itself. And then it looks like we have chlorine, and there are 4 of them. So CC, oh, whoops, I wrote too many carbon. There we go. CCl4 would be the molecular formula. And then the last one, phosphorus pentabromide. So phosphorus has the symbol P, and there wasn't a prefix, so we know it's by itself. And then penta means 5, and then it looks like we have bromine, so Br5. Okay, so we'll end here. In the next video, we're going to learn about something called electronegativity and bond polarity. So I will see you then.